Hello friends, in the previous episode we discussed the concepts of population dynamics and climate change adaptation. I hope that the understanding of both these concepts will have created an enormous interest among you to know more about issues related to demography and climate change adaptation. In today's lecture, I shall talk about the links between population growth and climate change. I shall also throw light on the impacts of climate change. Undoubtedly, rapid population growth and fossil fuel emissions are two leading characteristics of our modern age. Since 1800, world population has grown sevenfold, while per capita carbon dioxide emissions have increased 150 times. It has taken about 200 years of carbon emissions to create our current climate crisis. Without miraculous technological breakthrough, it is going to take centuries to set things right again. Since the Industrial Revolution, climate change has been dominated by humanity's use of fossil fuels and land and the consequent emission of greenhouse gases into the atmosphere. Demographers, population scientists, policy makers, and government agencies all over the world are worried about the adverse effects of overpopulation on climate change. Earth is a very special planet. It falls in Goldilocks zone or circumstellar habitable zone, where the conditions are just right for life as we know it. The circumstellar habitable zone, or simply the habitable zone, is the region around a star within which planetary mass objects with sufficient atmospheric pressure can support liquid water at their surfaces. To help keep these conditions constant, our planet is wrapped in a layer of greenhouse gases. This layer acts like a blanket, keeping the Earth warm and shielding it from the cold of universe. This is commonly referred to as the greenhouse effect. Carbon dioxide, which, while not the most potent greenhouse gas, is nevertheless the main driver of the greenhouse effect. Now, let us understand the basics of climate change. The primary energy source for Earth's climate is served as by the sun. Some of the incoming sunlight is reflected directly back into space, especially by bright surfaces such as ice and clouds, and the rest is absorbed by the surface and the atmosphere. Much of this absorbed solar energy is re-emitted as heat, that is long wave or infrared radiation. The atmosphere in turn absorbs and re-radiates heat, some of which escapes to space. Any disturbance to this balance of incoming and outgoing energy will affect the climate. For example, small changes in the output of energy from the sun will affect this balance directly. If all heat energy emitted from the surface passed through the atmosphere directly into space, Earth's average surface temperature would be tens of degrees colder than today. Greenhouse gases in the atmosphere, including water vapor, carbon dioxide, methane, and nitrous oxide, act to make the surface much warmer than this, because they absorb and emit heat energy in all directions, of course including downwards, keeping Earth's surface and lower atmosphere warm. Without this greenhouse effect, life as we know it could not have evolved on our planet. Adding more greenhouse gases to the atmosphere makes it even more effective at preventing heat from escaping into space. When the energy leaving is less than the energy entering, Earth warms until a new balance is established. Now, it is very important to know the main causes of climate change. Causes of climate change can be categorized into the following two categories: natural causes and human causes. We'll discuss natural causes first. The Earth's climate can be affected by natural factors that are external to the climate system, such as changes in volcanic activity, solar output, and the Earth's orbit around the Sun. Of these, the two factors relevant on timescales of contemporary climate change are changes in volcanic activity and changes in solar radiation. In terms of the Earth's energy balance, these factors primarily influence the amount of incoming energy. Now we come to the human causes. Climate change can also be caused by human activities, such as the burn of fossil fuels and the conversion of land for forestry and agriculture. Since the beginning of Industrial Revolution, these human influences on the climate systems have increased substantially. In addition to other environmental impacts, these activities change the land surface and emit various substances to the atmosphere. These in turn can influence both the amount of incoming energy and the amount of outgoing energy and can have both warming and cooling effects on the climate. The dominant product of fossil fuel ignition is carbon dioxide, a greenhouse gas. The overall effect of human activities since the Industrial Revolution has been a warming effect, driven primarily by emissions of carbon dioxide and enhanced by emissions of other greenhouse gases. Now, we'll talk about human-emitted greenhouse gases. Carbon dioxide. Carbon dioxide has both natural and human sources, but carbon dioxide levels are increasing primarily because of the ignition of fossil fuels, cement production, deforestation, which reduces the carbon dioxide taken up by trees and increases the carbon dioxide released by decomposition of the accumulation, and other land use changes. Increases in carbon dioxide are the single largest contributor to global warming. Now, let us talk about methane. Methane has both human and natural sources, and levels have risen significantly since pre-industrial times due to human activities such as raising livestock, growing paddy rice, filling landfills, and using natural gas, which is mostly methane, some of which may be released when it is extracted, transported, and used. Halocarbons, including chlorofluorocarbons, that is CFCs, are chemicals used as refrigerants and fire retardants. In addition to being potent greenhouse gases, CFCs also damage the ozone layer. Well, many CFC replacements are also potent greenhouse gases, and their concentrations and the concentrations of other halocarbons continue to increase. Nitrous oxide. Nitrous oxide concentrations have risen primarily because of agricultural activities such as the use of nitrogen-based fertilizers and land use changes. Now I am going to throw light on the role of climate in environmental system. The climate plays such a major part in our planet's environmental system that even minor changes have impacts that are large and complex. Climate change affects people and nature in countless ways, and it often increases existing threats that have already put pressure on the environment. But it is not a problem which has appeared overnight. It's been a very long time since scientists first alerted the world to the dangers of climate change. How much longer are we going to allow it to continue? This is the question which has to be answered sooner or later. Changes in nature have serious implications for people and our economic system. The insurance industry estimates the potential economic damage caused by the impacts of global warming to be hundreds of billions of dollars each year. Now we are going to talk about some other human causes of climate change. In addition to emitting greenhouse gases, human activities have also altered Earth's energy balance through some other activities. For example, changes in land use. Changes in the way people use land, for example, for forests, farms, and cities, can lead to both warming and cooling effects locally by changing the reflectivity of Earth's surfaces, that is, affecting how much sunlight is sent back into space, and by changing how wet a region is. Emissions of pollutants other than greenhouse gases. Some industrial and agricultural processes emit pollutants that produce aerosols, that is, small droplets or particles suspended in the atmosphere. Most aerosols cool Earth by reflecting sunlight back to space. Some aerosols also affect the formation of clouds, which can have a warming or cooling effect depending on their type and location. Black carbon particles produced when fossil fuels or vegetations are burned generally have a warming effect because they absorb incoming solar radiation. Now let us talk about the impacts of climate change. First, impacts on water. Rivers and lakes supply drinking water for people and animals, as well as being vital for agriculture and industry. Oceans and seas provide food for billions of people. Climate change will have major and unpredictable effects on the world's water systems, including an increase in floods and droughts. Extremes in droughts and flooding will become more common, causing displacement and conflict. Less fresh water means less agriculture, food, and income. Impacts on forests. Forests do so much. They purify our air, improve water quality, keep soils intact, provide us with food, wood products, and medicines, and are home to many of the world's most endangered wildlife. In fact, an estimated 1.6 billion people worldwide rely on forests for their livelihoods, including 60 million indigenous people who depend on forests for their subsistence. Forests also help protect the planet from climate change by absorbing massive amounts of carbon dioxide, a major source of pollution that causes climate change. Unfortunately, forests are being destroyed or damaged at an alarming rate by logging and burning to clear land for agriculture or livestock. These activities release huge amounts of carbon dioxide and other harmful greenhouse gases into the atmosphere. Scientists estimate that up to 20% of global carbon emissions come from deforestation, greater than the combined emissions of every car, truck, and plane on the planet. So instead of forests helping us to solve the climate crisis, deforestation is making the situation worse. Impacts on food security. Climate change will have a significant impact on food availability, food accessibility, food utilization, and food systems stability in many parts of the world. climate change poses a significant risk of increased crop failure, loss of livestock, and will impact on local food security. In some areas, drier and warmer conditions are predicted. Elsewhere, wetter and cooler conditions are expected, which will negatively affect agricultural practices. It will affect human health and livelihoods, as well as people's purchasing power, food markets, and food security at household levels. Now let us talk about impacts on agriculture. Many people throughout the world rely on rain-fed agriculture. As a result, it is highly vulnerable to changes in climate variability, seasonal shifts, and precipitation patterns. Any amount of warming will result in increased water stress. Roughly 70% of the population lives by farming, and 40% of all exports are agricultural products. 1/3 of the income in Africa is generated by agriculture. Crop production and livestock husbandry account for about half of household income. The poorest members of society are those who are most dependent on agriculture for jobs and income. Now it's time to talk about some of the facts about climate change. According to Intergovernmental Panel on Climate Change 2007 report, sea levels will rise by 7 to 23 inches by the end of this century due to global warming. Since 1880, the average temperature has risen by 1.4 Fahrenheit degrees. The last 2 decades of the 20th century have been hottest in the last 400 years, according to several climate studies. According to the multinational Arctic Climate Impact Assessment Report compiled between 2000 and 2004, the average temperature in Alaska, Western Canada, and Russia has risen at twice the global average. The Arctic ice is melting rapidly. By 2040, the region is expected to have a completely ice-free summer or even earlier. The Montana Glacier National Park has only 25 glaciers instead of 150 that were there in the year 1910. About 95% of African agriculture depends on rainfall. In Africa alone, climate change will expose 75 million to 250 million more people to increased water stress by 2020. Since the 1960s, the Sahel region of Africa has experienced a 25% decline in rainfall. Agriculture accounts for 14% of greenhouse gas emissions and forestry for 18%. It is calculated that the number of people affected by climate-related humanitarian crisis will rise by 54% to 375 million by 2015. Now we come to the conclusion of today's lecture. Rapid population growth is certainly the principal factor behind climate change today. Human-caused climate change is fundamentally an imbalance of scale as people release heat-trapping gases into Earth's atmosphere faster than the oceans and living things can remove them. The size of today's population and its continued growth also put at risk the social and institutional resilience needed to adapt successfully to the impacts of climate change, ranging from sea level rise to more extreme weather events. Slower population growth followed by a gradual decline in population size would facilitate future reductions in greenhouse gas emissions and help societies adapt to the changes in climate that are now all but inevitable, since due to the long lag times built into the climate system, they will be the product of emissions that we failed to cut in the past years and decades. Well, population is associated with sensitive issues including sexuality, contraception, abortion, migration, and religion. As a result, the debate on climate change also tends to focus on the role of human technologies and their economic foundations, along with on critical human numbers and behaviors. Now, citizens and governments have to choose among several options in response to this information. They can change their pattern of energy production and usage in order to limit emissions of greenhouse gases and hence the magnitude of climate changes. They can wait for changes to occur and accept the losses, damage, and suffering that arise, or they can adapt to actual and expected changes as much as possible. Alternative resources, conservation, improved environmental technology, and better education about global warming can ease our impact on the earth and serve as a new frontier for our future generations. Well, with this, we come to the end of today's lecture. In the next episode, I shall talk about population and land degradation. Till then, goodbye. Thank you very much.